Morning, class. Today, we're talking about methodology. And although today was supposed to be a fun and exciting video, I am feeling particularly heartbroken. So, we are just going to have to power through. Before we begin, I would like to explain that I am only guiding you through my process of how I solved this question. Much like computer science and perhaps many other problem-solving fields, there is no one perfect solution. My solution may not be ideal or optimal. In fact, it may not even be correct. Really, you can do everything right. And at the end of the day, truly, things might still not work out in the way that you wanted them to. And that's life. I mean, you can't change how other people feel about you, but we can change spatial data to suit our needs in solving this problem. And so that's what we're going to do right now. One of the first steps that I looked at when analyzing this map were these three-way boundaries. Now, I thought these were very useful because it makes sense to me that I would be able to walk through three prefectures in a very short distance by walking a very simple triangle around the center point of those three boundaries. So, one of my first goals is how can I identify all of these three-way points? And so one of the first things that I'm going to do is use a tool here called Extract Vertices. And it's going to do what it says it does. So we can see here in our new layer that we have all the points from all of the shape file datas. And so this is useful for us because we can now identify some vertices. However, it's too much data. It's hard to see here, but we have approximately 48,000 points, a lot more than the 10,000 data points that I mentioned yesterday. And so we need an automated solution. Now, I'll give you a few seconds to think about what we've just done and take time to notice a strange quirk of redundancy that we could potentially use in part of our solution. You might have already noticed that all of the prefecture shapes share the same border spatially, but not the same data. What that means is if I were to select this center point here and go to the attributes table and pull up what I have selected, I get 3 independent points. And these 3 independent points belong to each of the 3 bordering prefectures. That gave me an interesting idea on how I could isolate these redundant points. What I'm going to do is I am going to buffer. And what a buffer does is it just takes a shape and it just adds some space up onto the edge. We now have vertices and we now have buffers that mirror the vertices. However, the buffers are not vertices. The buffers are a shapefile, meaning the buffer actually encapsulates the vertice. The vertice might look larger than the buffer right now, but in reality, vertice data points are infinitesimally small. The buffer will always be larger than the vertice. And now we can use that property to help us. So before I continue, I'm just going to do a little bit of magic here. You don't really need to know what exactly is going on behind the scenes, aside from the fact that I am making life easier for myself. Okay, excellent. Okay. So, don't be too concerned with what is on my screen right now. But understand that because multiple vertices share the same spatial location, and a buffer is in that location but larger than the vertices, we can use a function called countInShape to count how many vertices exist within the bounds of each of those shapes. Single parts with vertices, and we run that. I forgot this is going to take a really long time. Finally, it's done. Now we have a layer called count, which is a shape equal to the buffer with the added feature that it has a field that counts how many vertices exist in there. So if we go here, it's called numPoints. And you can see that most, at least a lot of these, are only 1, meaning that there is no redundancy in any of those vertices. So likely, it's one of these that exist on the coastline. We also have a fair amount of 2s and 3s. And so what that equates to, 2 would be a vertice that is shared between 2 boundaries, and 3 are the spicy ones that we want that are shared between 3 boundaries. Now I'm going to do a bit more magic that helps me visualize everything that I'm doing. So you're gonna have to give me a quick second to work that through. Now we have what is essentially a layer that is completely equivalent to the vertices in our first step of data processing with the count value of vertices. I made this mistake the last time I recorded this. If I go here and I select by expression, we could technically select by features, but this is a completely different operation. So what we want is actually select by expression. And we're looking for numPoints equal. We only want 3. And now when we look at our data, we're going to see at every 3-way juncture, that point has been selected. So I should probably just explain. So we're going to take all of our selected features and make a new layer out of only those. Only 3. Cool. I forgot I need to... Oh, stupid things. Field calculators. Sorry, I need to fix this a bit. Where's the field calculator? Id, decimal, integers, operators, record. Oh, this is why I wanted id. I'm so silly. Ugh, damn it, I did it again. Can I? It's so annoying. And my heart's broken. What the heck? I don't need to make a new one. I just need to update FID. Okay, there we go. Now I need to select by this again. Num equals 3. Okay, we now have a layer that only has the 3-point intersections. We only have 75 data points to look through now. Isn't that amazing? Now, we're still going to get outliers, like this one over here. I would like to add, as one note, data cleaning is not only the first thing you do in your problem-solving process. It's actually something that ideally you should be doing all throughout your process. And at this stage, I'm actually going to data clean one more time. And I'm not going to record it because it's not interesting to watch. But basically what I'm going to do is I'm going to look at data points like this, or for example, like these, or potentially even this. I'm not sure how exactly that got through my filter, but this will be useful for us in the analysis. So, yeah. Take care, I guess. If you have any questions, I also have a lot of questions.